Onward to our second video about the topic 1 review. We're going to do measurement uncertainty and error propagation. Well, first we're going to talk about sig figs. Now the rules of sig figs are here. I'm not going to go over them because you probably already know them by heart or just have used them so much. But just remember, let's see, scientific notation. The number of significant figures is the digits in the coefficient. So this is the coefficient right here, right? We're not worried about this stuff. And then for a logarithmic function, you may not know this, like when we do pH calculations, and this will show up later, it's the number of decimal places that are there. Okay, so that first one does not carry any actual significance. All right, but a great note that IB doesn't really care about sig figs on a written test. On the IA, they will care and they will write comments on it and deduct points. But for a written test, nobody really cares. You can just don't go crazy with the sig figs. So let's try to find the number of sig figs here. It's going to be 2. And then this one, let's see. So there's no decimal place present. So that one, that one, that one, that one, that one, that one. So 1, 2, 3, 4, 5, 6. There's 6 sig figs here. There is a decimal place. So after the first significant digit, everything is significant. So that's 3. The numbers in the coefficient, 1, 2, 3, 4. And then we want to round this to 3 sig figs. So we'll take the first 3 that we see, and we're going to round everything off. So that's going to be 6, 3, 0, 0, 0, 0, 0. Okay? And so we need to show that this 0 is actually significant though, right? So we're going to put a bar over it, or we're going to put it in scientific notation to get around that. Okay, 1, 2, 3, 4, 5, 6. 10 to the 6th. Okay? Now I did these right here just because I don't want to waste your time doing math. Math you already know. But when we are adding and subtracting, we're going to take the least number of decimal places. So the least number of decimal places is 2, so that's just 2 sig figs. The least number of decimals we're adding again, so the least number is 1. There's 1. Now, when we're multiplying and dividing, we're going to use the least number of sig figs. Well, this one has 3, this one has 3, so this one has 3. So now this one has 2, and this one has 3, but we're going to have 2 in our answer. By the way, the 10 to the 100th power will break this calculator, and it won't let it do that. So I guess it can't compute numbers that high. So FYI, found that one out. So change that to 10 to the 10th. Now, let's go to what everybody's favorite, uncertainty. So there are 2 things of uncertainty. There's the absolute and the relative uncertainty. The absolute is what we normally see. So the absolute uncertainty here would be the plus or minus 1, right? But the relative uncertainty is called the percent uncertainty. What we'll do is we'll take the absolute uncertainty and divide it by the reported value. So we'll do 1 divided by 12 times 100, and that will give us our answer, which I've got on my cheat sheet here, is 8.3%. The absolute uncertainty right here is plus or minus 0.01. And then the relative is going to be 0.01 divided by 1.04 times 100. And that's going to be 0.962%. And then this absolute uncertainty is plus or minus 0.01. And then the relative is 0.01 divided by 85.56. I will scoop that up. Times 100. to give us 0.0117%. So as you could see, as we went, the uncertainty became less and less significant right here. It was very significant here, and this is how you would try to limit this out of your data. You want it looking more like this. And on a word of note, whenever I see this 0.01, please don't write 0.1. Okay? That is confusing, especially for the readers, because you'll get lined paper on your exam, and if you write at 0.01, I wrote that darkly, but if you write this, it looks kind of weird, right? So please always write 0.01, all right, especially on your IAs. All right, that's going to bother me if you don't. So that's one little pet peeve I have. All right, now when it comes to error propagation, so for addition and subtraction, you will just always add the absolute uncertainties. Even if you were subtracting, you were still going to add. I know it feels weird. So like if you were doing a change in temperature, if you were heating something, right? You would do final minus initial, right? So let's go ahead and try that right now. 27.9 minus 20.1. Easy. That's going to be 7.8. Now the uncertainty is you're going to add these two together. Don't need a calculator. It's going to be 0.02. All right. So a solution is prepared by adding 50 with this decimal place right here, grams of water to 100 grams of sugar. What's the smallest graduation balance for the sugar? That is going to be 0.01, right? And the graduation balance used for the water, that's going to be plus or minus 1, right? Now the total mass of the solution is going to be 51, right? So now, according to our rules of sig figs, there's two sig figs we are adding right here, but we're going to add with the least number of decimal places. So this one has no decimal places, so this one will also therefore have no decimal places. Now, we'll do our uncertainty as well, and we need to add these uncertainties together. So we have 1 gram. Now, would using a more precise balance for the sugar right here result in a more precise total mass? What that's saying is, if we say we had a precision that did that, would that make a difference? No, because it would get wrapped into this, and then and the moral of the story is that it's the largest uncertainty is the one that is your, I guess, quote, air quotes, limiting uncertainty. So multiplication and division. Now in a scalar, you are just going to multiply by that absolute number. So this is like if I had 3 apples, right? Something I am absolutely certain about. I'm going to multiply this by this. So that is going to be 36.9 plus or minus 0.03 meters. Now, I won't multiply the units. So now calculate the area of a rectangle. Let's say the rectangle was this, and we had 4.8, and then 13.7, and then plus or minus 0.1, plus or minus 0.1. What you're going to do is you're going to add the relative uncertainties. Here, I'll just show you all the trick. Do 4.8 times 13.7, and we're just going to find the actual area for that and ignore uncertainty for a second. I already did it on the cheat sheet. Give me a sec to pull that up. It is going to be 65.76 for that value of the uncertainty. Now, then we're going to take the relative uncertainties here, 0.1, and we're going to find the relative uncertainty for this one, and we're going to add it to the relative uncertainty for this one. Okay, so here in one simple function, we're going to add those together and get an answer, which is going to be, I swear I wrote this down, 0.1 divided by 14.8. Let's do 0.1 plus, 0.1 divided by 4.8 plus 0.1 divided by 13.7 gives us 0.0281. So I, first of all, and then I'm just going to take this number and multiply by that number. And that's going to be 1.85. That's my uncertainty. Okay? So now I didn't round for sig figs here. I didn't do any of that because I wanted to make the best guess when I do this uncertainty. It might make a difference later on at the end, right? So let's fix our sig figs here. We use 2 sig figs, so our answer should have 2 sig figs. So our answer should be 66. And then we are going to take the uncertainty, and it should only have that first sig fig right there. So we're going to round that up to 2. So it should be 66.2. Now your units should be centimeters squared. Cool, right? All right. Now for this one, this is going to be, we're going to do 44, this stuff divided by this stuff. So 44.01 divided by 2.1 is 20.96. We'll do 0.05 divided by 44.01 plus 0.05 divided by 2.1, and then we are going to multiply all of those by 20.96, and that will just show us our uncertainty. It's a little bit different than this step. I think that has too many numbers. So, and that will give us 0.52. All right. So we'll round that to 1 sig fig. That's our uncertainty. And we're going to round this one to its number of sig figs, 2 sig figs, because that's the least number. So we're going to do 21 plus or minus 0.5. Okay. I know that seemed complicated, but really all you have to do is take your true value, calculate that, store it, save it, take your relative uncertainties, and then add it to the next relative uncertainty and keep going until you added all of them together, and then put it in parentheses, multiply it by that true value that you had. That's where I got this number from. And then you get your final uncertainty. Now here we go with this weird one, because the significance of the uncertainty does not match this one. Some people say you should do 21 plus or minus 1. And then some people say you should do 21.0 plus or minus 0.5. Now, if that actually happens in an experiment, let's talk about it. All right? Or your IA. Let's talk about it. It will not happen in your written exams. They will set it up so that never happens. But the IB doesn't really care. They would accept this value. All right. So that's going to be it. Have a great day.